now we are going to discuss about deflection test on simply supported beam. The aim of this experiment is to determine the Young's modulus of the given steel simply supported beam. Right. So this is a experimental setup. So this is the left support. This is the left support. This is the right support. This is a beam. This is a beam. Here we are applying the load. Here we are applying the load. Here we have the instrument for measuring the deflection. When you apply the load, the beam will be deflecting. So at this location, we are measuring the deflection, right? Dial gauge. Using the dial gauge, you can find the deflection. That is for different loading conditions. The support, this support to this, the distance is 1050 millimeters. 1050 millimeters. Here load is applied. Here deflection is taken, right? So in this, this distance is A. This is A. This is A. And this is B. This is B. And this distance is X from the support to the point of measuring the deflection. This is X. This is X. This is A. This is B. What is L? L is equal to A plus B. A plus B. That is the L. So this value is from the left support. The point of deflection taken is X. So these are all the important dimensions. So this is a dial gauge. This is a dial gauge. Here you can get the value of deflection. Now you apply here you apply the load of 0.5 kg. That is 500 grams. Then you find the deflection at this point. Find the deflection at this point. So this is a dial gauge. In the dial gauge, you can get the deflection. So the same procedure you have to repeat for 1 kg, 1.5 kg, 2 kg, and 2.5 kg. Right? So here we have the apparatus. Then what are all the dimensions you have to take? Already I explained. L, this is the length of the beam. And A, what is A? Distance of the load system from the left support. What is B? Distance of the load system from the right support. What is X? It is distance of the deflection from the left support. And the breadth of the beam is 20 millimeters and depth of the beam is 10 millimeters. Right? These are all the observations. And this is a tabulation. We have the loads. You convert the load into Newton. So it is in kg. So then multiply with 9.81, it will give Newton. So during loading, you have to take the deflection. Similarly, you have to take the load, you have to take the deflection during unloading. Then you take the mean value and divide the value by 100. Divide the value by 100, that will give in millimeters. Then finally, you find the Young's modulus using the equation that is given later. This is for trial 2. So here, initially, we fix load here, loading system here, and deflection here. So while taking the second set of reading, you replace both. You keep the loading point here and deflection point here. You replace that. You can see here. Here, see, loading point is here and deflection point is here. We are replacing it. We are replacing it. By replacing, you can get the deflection the same way. So now you can check if you apply the load here and finding the deflection at this point. Similarly, if you apply the load here and find the deflection at this point, both must be same. What is that? That is a Maxwell theorem of reciprocal theory. Maxwell reciprocal theorem. Already you have studied in theory. Observations, tabulation. Again for trial 2, observations. Then for that also tabulation. For each load, take the deflection in during loading, during unloading, mean, and divide by 100. Then find the Young's modulus. So this is a equation to find the Young's modulus. This is a equation to find the Young's modulus. Y, this is a deflection that we get in from the dial gauge. W is a load. You substitute in Newton. B, you substitute the distance in millimeter. X also, already we have the absolute value. You substitute in millimeter. L value, B value, X value, 6, I, and L. E you have to find. You have to find the value of E. X modulus you need to find. What is I? I is equal to B d cube by 12. We have the value of B. We have the value of D. L is 1050. So by in this equation, by substituting all other data, you can find the value of Young's modulus. The same thing you repeat for other readings also. Other readings also. Then model calculation. Finally, you draw graph between. You have to draw two graphs. Two graphs. We took two set of readings. Here you take the load. Here you take the deflection. You draw a graph for first set, for second set. Finally, you write the results. Finally, you write the results. Here for Young's modulus for trial 1, Young's modulus for trial 2. So this is the way you have to do this experiment. So this experiment is deflection test on simply supported beam. Deflection test on simply supported beam. Here see, this is a simply supported beam. Here we have one end. Here one support is there. We have another support here. So what is the span length? The span length is 1050 millimeters. 1050 millimeters. That is the total length of the simply supported beam. The distance between the supports. See here, you can apply the load here. You can apply the load here. So distance of the loading point is 300 millimeters. 300 millimeter from the left support, and the length of the dial gauge point from the left end is 600 millimeter. The total length is 1050 millimeters. Now we apply. So now when load is applied at this point, what will be the deflection? You can measure the deflection. Each one is 500 kg. We have masses. Each mass is 500 kg. So first you apply the 500 kg and take the displacement. 500 grams. Now you apply the, we have different loads, each of 500 grams. You apply the 500 grams initially and take the reading in the dial gauge. What is the deflection at that point? Now you apply the 1 kg, that is 1000. So by applying different weights, you take the deflections. So you can take for 5 readings. So from the 5 readings, the objective of the experiment is to find the Young's modulus. We know the relation between the load and deflection. That's the equation. So using that equation, you can find the Young's modulus. That is the purpose of this experiment. Now let us see how the experiment is conducted. Sir will demonstrate it. Now see. Now sir is applying the load. This is first 500 grams. 500 gram is applied. Now he is taking the reading. 30. The reading is 30. You have to multiply with the least count. Reading is 30 and multiply with the least count. Least count is 0.01. 0.01 is the least count for the dial gauge. The reading shown is 30. So 30 into 0.01. So that is the deflection in millimeters. Now sir is applying the second load. It is again 500 grams. So initially 500 grams, again 500 grams. Now we applied the 1000 kg. The deflection is 60. So what will be the mm? 60 into 0.01, least count. 0.01, that will be the deflection, 60 millimeters for 1 kg. Now he is applying another load. It is again 500 grams. 89. So the reading is 89. So 89 into how much? 0.01. That is a millimeter. So now the fourth load, it is again 500 grams. Now the total load is 2 kg. The reading is 120. Then the deflection in millimeter is 120 into 0.01. So that is a deflection. The fourth load, it is 2.5 kg totally 2.5 kg. The reading is 149. It's showing multiplied by 0.01. That will be the mm. Now unloading. So you are going to see the reading during unloading. Now 500 gram is removed. The reading is 118. The reading is 118. So for 2 kg during unloading, it is 118 into 0.01. That will be the mm. Again, he is removing the another load. So 500 gram is removed. Now the load is 1.5 kg. That the reading is 90. 90 reading multiplied by 0.01. Okay. Next, again, he is removing the 500 grams. Now the load is 1 kg. Reading is 59. 59 into 0.01 is the millimeter. Reading in millimeter. Again, sir is removing another load. Now the load is 500 grams only. 29. The reading is 29. So 29 multiplied by 0.01. That will be the millimeter. So these are all the reading we have taken. So here we are using a beam. We are using a beam. The size of the beam is width is equal to 20 millimeters. Thickness is equal to 10 millimeters. Width is equal to 20 millimeters. Thickness is equal to 10 millimeters. These are all the reading. With that reading, with the available equations, you have to find the Young's modulus of this beam. Our objective is to find the Young's modulus of this beam, right? We kept the mass at this location. What is this location? It is 300 millimeters from the left support. Now the dial gauge is 600 millimeter from the left support. Now you can interchange the load and the dial gauge. You can interchange and you can take the reading, right? You keep the dial gauge at 300 millimeters and keep the weight at 600 millimeter from the left support. The same set of reading has to be repeated. You repeat the same thing and take the reading and calculate. So you can find Young's modulus using that also. Okay, this is similar to Maxwell's law. You may be knowing Maxwell's law. The load applied at point A and deflection at B, that will be equal to load applied at point B and taking the deflection at A. This is a Maxwell law of reciprocal theorem. You may be knowing that. So this is, you can also confirm the Maxwell's law of reciprocal theorem using this experiment. That is applying the load at point A and taking the deflection at B. That will be same as applying the load at point B and taking the deflection at A. That is Maxwell law. That can also prove using this experiment.